the visible my screen?
No, sir.
Now?
Sir, you can.
Okay. So conditional compilation and execution. So compilation and execution, compilation is nothing but what? So translation. Compile the code. Okay. Then execute. Okay. So what is the conditional compilation and execution? So that means compilation can be done with a condition. Why? What is its importance? Its importance is very simple, that whatever the code, Verilog code you have written, that code may not be, should be run in different environments. So the entire code may not be suitable for one environment. So that means it may need two environments or three environments like that. But you cannot, designer cannot write, you cannot write the code for the different environments. So that you have to give some portion, which portion is required to execute in this environment, and what portion of other portion to execute in another environment. That you can make the division of the compilation in different environments, okay, by making the condition. Okay, note down. Conditional compilation and execution. Note down. A portion of Verilog is suitable for one environment and not for other. To create two versions of Verilog design for the two environments, is difficult task. Hence, we can specify that the particular portion of the code should be compiled only if a certain flag is set. This is called the conditional compilation. Similarly, to execute certain parts of the Verilog design, only when a particular flag is set to run. This is called conditional execution. Okay, please stop. For conditional compilation, the keywords are Keywords are, so first one, if def, single word. So I think you asked me about your less marks in the first mid. In the first mid, I wrote the comment also in the first mid. So everywhere in the program, you wrote end module as 2 words. Yeah, everywhere you wrote. That is the main.
Yes, sir. Yes, sir. Yes, sir. Even in programs while we are in writing code in lab, we did that.
Okay, okay. So if def is a single keyword, if def, okay, another keyword is else, and another keyword is and if. All are single words, no space. Okay, so the syntax for this conditional compilation is, see the code which is on the text, which is on the screen. See, example 1 is there. If def test, if def test is a what? Is a I think macro. That means a separate what is that one? Procedure. Okay, so if def test, so module test is there. See below that module test is there. If this flag is set, if def is 1, this will run, this will compile. What? So the module whose identifier is the test will be executed only if def flag is 1 or is equal to 1. Okay, and the module else, if it is 0, if the flag is not set, so then one more module will run. See, if this is true, this module will run, module will compile, not run, compile. And if it is a false, then another module will. These 2 modules may require the 2 different environments. So you are controlling to the different environments. Your program will what is the one? So switching between the 2 environments simply by what? Setting a flag. That is called the conditional compilation. Okay, so and module, if another one is there, then and if you can write one more thing. So see the example 2. This is the module top. Module, the identifier is the top. Okay, object name is what? Top. Bus underscore master B1. Okay, so that means this is the module. There is no condition here. See, in the example 2, I think module top will run without any condition. Am I right? I did it earlier. So in the example 1, starting is what? If def is there. So that is a condition. The condition will test first based on the condition result, whether true or false. If true, one module will run, will compile. If false, another module will compile. In the second example, the module identifier is what? Top. Okay, so instantiate module unconditionally. What is that instance? So bus underscore master B1 is the instance. Later, so if def add underscore B2. Okay, if def, okay, add underscore B2. Yeah, add underscore B2 is the what? So what is that one? That is a module name. Bus underscore master. Okay, so B2, bus underscore master B1 is there without any condition. So now B2. So the B2 is instantiated conditionally if 2 macro, if the text macro, what is that macro name? So add underscore B2 is defined. And if and module. Okay, and if anything is there, you can write. But the keyword is what? So if def, else, and if. Yeah. So note down. If def statement. If def statement may appear anywhere in the design in the HDL design, anywhere in the HDL design. Designer has a choice of, designer has a provision that he can conditionally compile statements, comma, modules, comma, blocks, comma, declarations, comma, and other compiler directives. Full stop. In conditional compilation, else underscore it is optional. Maximum one else. If you want to write, if you want to include maximum one else is acceptable. If you want to include maximum one else is acceptable. Okay. If def is always completed by and if. That means first if def and last and if. Okay. Conditional compilation flag can be set with defined statements inside the Verilog file. Define is a keyword. Here you want to observe one thing. See, all these keywords should have a what? Single quote. One side, left hand side, one quote is there. Apostrophe, simply like that. You should mention that one. You should write always. If def, first put the quote. So else put quote. And if put quote. Okay. And define also put quote. Okay. All these are mandatorily having these quotes. This is the difference from other keywords. Similar keywords you can find in the, I think, the module. But how you can show them these are different from them is by writing the what? Single quote. One side single quote or apostrophe you can say. Okay, that is. Okay, what I told you? Conditional compile flag can be set with defined statement inside the Verilog file. Okay, so I think you are going to test the flag. If def. Okay, but how the flag, where is the flag? It can be either set or reset. I think that routine should be inside. Yeah, you must aware of that. Okay, so whenever you what is it one? You have two options. What type of decision will take? Okay, that type of decision you can take. Okay, so actually in the what is it one? In the example, we wrote the two examples. We observed the two examples, example 1 and example 2. Okay, so in both the examples, generally the flag, define the flag by defining the text macros test, TEST test. Test is a flag. Test, okay. And another one in second example, there is a add underscore B2 at compile time by using the define statement. Okay, so these two may set the flag. Okay, understand? So how to set or reset the compilation flag is, so that routine should be written by you, means designer. Okay, so whatever the flag, we can define the flags, okay, by defining the text macros. The language is, don't forget, text macros, TEST test. That is in the first text macros. Two text macros are there. Test and add underscore B2. This macros generally, I don't know whether you completed traffic implementation of the traffic signals in the lab. Okay, so at the time, whenever you are going to implement the FPGAs, then macros should write. Without macros, simply off adder and full adder or these counters does not require any macro files. So when it goes to the complex circuits, then macro files are required. So that also you need to put in addition to these things. So that is called the macros, text macros. Okay. Next, yeah, you can define these two macros, that is text macros, that is test and add underscore B2. Both will be, I think, so you should define during the compilation time. Okay. Yeah, you can write, include that statement. We can define text macros. TEST test, capital letters, and A and N, add underscore B2 at the compilation time with the define statement. Don't forget to write the define, as I said, as we discussed it just before. Okay, understand or not? If the flag is set, that particular portion will compile. If the flag is reset, it will be skipped to compile. Next one is conditional execution. Conditional compilation, conditional execution. Conditional execution flags. Conditional execution flags provide the facility to control statement execution flow at runtime. These flags can be used only for behavioral statements. Here, all the statements are compiled but conditionally executed. All statements are compiled but conditionally executed. For conditional execution, system task keyword system task keywords $test system task keyword $test continuous single word $test plus arguments args. So this is the system task. Generally this keyword is used for the conditional execution. In the conditional execution, compilation I think performed for all, but execution sequence or execution statements are changing. So I think this is while we are discussing this one, we may recall one thing, that is what? Timing control statements. Timing control statements. At what time the statements should be executed, okay, or simulate. So you can control by using the different timing control statements, like what? So timing delays you can have. The role of this conditional execution, or the role of the keyword $test plus arguments is similar. Okay. This facility is available in Verilog Excel only. I think simulators which is used for the Verilog Excel only accept these things. The other simulators are not accepted. Okay, every simulator has to understand something. Okay, see on the screen there is an example for this conditional execution. Yeah, module test, some statements initial begin if, in the bracket I'm writing $test pulse argument. What is that one? Display underscore variable. Okay, so next $display. So display is binary value, and so concatenation of ABC. Okay, so here is display only if flag is set. Okay, so if in the bracket whatever there after begin, that means whatever there means inside there is a flag. Which flag is there? Conditional execution flag is there. If this flag is 1, this statement will execute. If this flag is 0, this statement no display will get. Clear? So this is the way of, I think this is just like your if statements or something. Okay, so that means if the what is it, condition is true, okay, some particular sequence will execute, otherwise other sequence will execute. All are looking similar, but the application point of view, so there is a difference. The variables are displayed only if the flag display underscore variable is set at runtime. Okay, this is the argument is this one, display underscore where is the argument. If this is set, then this is the next statement will execute. If this is not set, I think after else the statement executes. Flags can be set at runtime by specifying the option plus display underscore where at the runtime. If you want to set a flag, then you can use this option also, no problem. Yeah, next one is time scales. Yes. So this is the first important thing we should discuss. So before this course, but but we are discussing this at the last. So if you take any HDL code, okay, if you are doing simulation, then so they will execute with with reference to some timing units, maybe picoseconds, maybe microseconds, whatever maybe. But how it taking its own? If you are not mentioned by default, some timing units it will be taken. So otherwise, if you want to change, if you want to specify some other timing units, then you need to specify at the beginning of the HDL. Okay, clear or not? Time scale is there. There you should write your option. That must be the first statement. Later the module is there. Then you are changing the timing units, by default time units, as your requirements. Clear? That is called the time scale. See here, time scale compiled directive is there. Listen. So there is a what is that one? Apostrophe time scale. Okay. So there is a reference time unit by time precision. There are two components are there. Reference timing units, microseconds, and precision. How much precision is required? How much precision is required? Nano by pico means nano is the units and pico is the precision. So the two parameters, two components are there in the what? That statement. Time scale is a single keyword. After that, we should give the space and write the what units, which units are you are referring, slash precision. Okay, so no doubt time scales. Verilog HDL accepts reference time unit for modules with the compiler directive. So time scale, underline the time scale. So put quote on the top left side. Syntax is what? Time scale, reference time slash precision time. Okay, reference time infers unit of measurement for times and delays. Okay, please stop. The precision time defines the precision to which the delays are rounded off. Precision to which the delays are rounded off during the simulation. Okay, only 1, 10 comma 100 are valid integers for specifying timing unit and time precision. Yeah. See, here are the two examples on the screen. One is the dummy 1 module, another one is the dummy 2 module. Okay. Clear? One is the dummy 1, this is, and one more is the dummy 2. Okay. So what it may be, but you should understand one thing, that is here. You should notice this one. Okay. This is the using of what? Timing? Timing? Huh? Time scales. Using of time scales is the first statement in the module. Am I right? Okay. Yes. Here is what is the time units here? 100 nanoseconds. Suppose if you take 5 into 100 nanoseconds, that is the value. Okay. And precision is 1 nanosecond. Precision is 1 nanosecond. Okay, see this example, module dummy 1, RIS toggle. Toggle is a what? Variable. Okay. Toggle is a variable. So which is maybe output or some other thing. It is a register type variable. Register data type, you can say. Register data type. Initialize toggle. Initial toggle is equal to 0. Okay. So flip the toggle register every 5 time units. In this module, 5 time units is equal to and 100 nanosecond into 5. 500 nanoseconds is equal to 0.5 microseconds. Always. See, here is after this is the only explanation comment. Now always hash 5. Always hash 5. Always after 5 minutes of time, this should be execute. What? Toggle should be negation of toggle. And display the values, toggle values in decimal or binary or some time also. So in this example, so the program is the HDL code is for only what? To make the toggle value change for every 5 minutes of time. 5 units of time is 5 is my value into what is units of time? 100 nanoseconds. 100 nanoseconds. Now multiply both. That is the actual time. Clear? So here I got 0.5 microseconds. For every 0.5 microseconds, what? The toggle value, initial toggle value 0, the toggle value changing. Is changing means what? Toggling. Okay. So that is the one. Next, so define a time, second module, second example, dummy 2. So see this statement here. This is actually we are talking about this one, time scale. This is my time scale. Time scale, I am defining 1 microsecond by 100 nanoseconds. One thing should be understand. So unit should not be less than the what? Precision. Nanoseconds are more or microseconds are more? More. Okay. If it is a ulta, it's wrong. If you write time scale 10 nanosecond by 1 microsecond, it's wrong. Understand, Karthik? Yes. Okay. So now I think only at this moment of time we should talk about only the rest of things we don't want. So the simple code is what the code is doing is simply what? So the toggle value, whatever its initial value, will be what? Toggle change for every some amount of time units. Okay, that is a very simple question, simple code. But your job is At what time the actually it's time units are specified, delay you are specified. Okay, so now actual time, simulation time you can calculate. Actual simulation time you can calculate. Earlier, before that, so 5 means 5 plus 20, you are calculate like that. This statement will execute at 5, then this statement will execute at 10 means, then the time total time is 5 plus 10 in the series sequential, or each individual is maximum time, simulation time is 10 in parallel block. We understood in that way. But now that 5 is not because so I think we didn't talk about what is it one at that time. We didn't talk about this time scale. Since you understand now the time scale and how you define the time scale, then you should say exact values. You can able to say exact figures of the simulation times. Here I told you what 5 means. 5 is multiplied with the, what is your units? Okay, what is your units? 1 microsecond or 10 microsecond? Okay, I will show you, don't worry. Yeah, 1 microsecond. 5 into 1 microsecond is equal to 5 microseconds. Okay, that is equal to 5,000 nanoseconds. 5,000 nanoseconds. Okay. Yeah, begin what happened. So after 500 nanoseconds, your flag, your toggle bit is changing. Is what? Toggling. It's toggling. Means if it is 0 now, then after 5,000 nanoseconds, its value becomes 1. Later, after one more 5,000 nanoseconds, it becomes 1. So like that, what happened? So your bit will be toggled. Okay, so that is the theme of the program. Here is explained like that. At 5, see on the screen, 5 toggle is 1, 10 toggle is 0, like that. You can add. Okay, 5 plus 5 is 10, plus 5 is 15, plus 5 is 20 in the way. Okay. Yeah, got my point? Yes. Next, useful system tasks. Useful system tasks. Yeah, we'll discuss this in the next class. Yeah, you ask me any doubts. If you have any doubts, you can ask me now.